Hello, hello. Happy Wednesday. How's it going, y'all? Hey, Diginanigans. How are y'all doing? Let me just transition the music from our very cinematic intro music to something a little more, I don't know. Maybe a little less would be a better way to describe it. How are y'all doing? We're halfway through the week. I just got approved to be in the beta for 2K streaming on Twitch, so I might try to set that up as an experiment this weekend. That'd be cool. Check that out. No stream tomorrow. I have the day off. But we'll be back Friday. And then Saturday, I think we're gonna have a special stream. I think we're gonna play Void War. And we might just be playing Void War on the weekend for a while. I think that'd be fun. Play it, think about it through the lens of like our own game. What works, what doesn't work. Stuff like that. All right, but let's get to it. I did some work yesterday. I know we've been struggling with the cutaway system. I did some work yesterday that I think will help us. I'm hoping to have this finished up by Friday. We can move on to something else. I realize we've spent literal weeks on this, but you know, I think it's one of the most fundamental things of the game, which is how does the player interact with the stuff. We're gonna do a kind of terraced. We're gonna do a kind of terraced look. Let me see how I can provide an example of what that would be like. I've tried a bunch of different methods, and it's a little hard to keep straight which combination of things I need to enable and disable to do that. But yeah, I think we're gonna utilize is we already have a thing that I call the compartment hierarchy, where during the floodfill system we figure out which compartments are directly in front of other compartments. I think I'm gonna modify that process a little bit, and we're gonna use that to inform this terraced cutaway look that's compartment based. So if I'm right, this will show kind of the terracing backwards, like up and away from us, which is a good start. It's not using the process that we're ultimately going to use, but just as an example. So you can kind of see it back here. You can kind of see it goes up and away. And I kind of like this because it gives you, it's most likely, this view I think is most likely to give you like incidental additional information about what might be going on. And I think I'm actually going to kind of go more extreme with it. I think we're going to use the compartments on the Z level of the cursor to inform the cut up. And then we're going to, once up or down, we're going to look at the compartment that's there next to it. And we'll use that as, we'll essentially repeat the process as we go up and as we go down. So there's just going to be this kind of, this only goes up, it doesn't go down. So like if I go up to this level and do the same thing, it continues to go up and back, but it doesn't terrace down and forward. I mean, there's no way for it to at the moment because of how this is. But I think that's what I want. I think that's how we're going to do it. And we're going to achieve this with this compartment hierarchy. So I think the first thing that would make sense to do would be to refine the process for generating the compartment hierarchy. So right now we have this case which is if negative z block is not equal to default and bit.has negative x block parts and negative y block parts and bit.count parts is equal to 1. So this is the thing that lets us go up and down. So this says, okay, this compartment is above us. So let's note that. I'm going to get rid of that. Compartment adjacency is just going to be on the same Z level. Have a great stream. Thanks, Pheasant, SC2. So I think we're going to get rid of this element for a moment. I think that's fine. And that will keep Z stuff from happening for us, like mapping onto compartments on different Z levels. That's the only change I think we need to make there. And then what we need to do here, well, for one thing, we need to know about the part hierarchy, which is the short form way that I say it. So we're going to say part hierarchy equals this. We'll just declare it for now. And so we're going to want to use this during the mask step, probably. Do we still do the mask? Like, do we still generate a mask? I think we do. I think we generate a couple of things. So the idea, so we have this walk the hierarchy recursive function. Well, it's the individual step that we use in a recursive function. And so we're going to use this to go through each compartment. What we might not do is we might not do this recursively because I don't think that's what we want. Maybe it is actually. So for our Z level, what we do is we walk the hierarchy from the compartment that the cursor is in. We don't do any cutaway at that point, except at the very edges. And then we walk the hierarchy again from those adjacent points. And then everything after that, we just cut away completely. So in fact, we could add all of that to the mask and then use the hierarchy to inform the cutaway part. Okay. So we'll write like a new function just so we don't mess up what we've already got going here. In case anyone comes in, they can at least look at what we're doing. So what we're currently doing is the mask blocks by cursor compartments. And then we are... Where's the next function? There's a lot of commented out code. I've tried this a lot of different ways. And then we cut away blocks by compartment mask. And then we do an interior cutaway by cursor cohorts as the last thing. So let's start reworking this. So what we're gonna do, we've got our hierarchy. The old way we had this was this cutaway blocks by compartment. We can look at this for inspiration because this is how we did the recursion. So we would get the cursor. We would say, you know, if the cursor is not contained, whatever. I think we have a check for this actually somewhere else, so we don't technically need it here, but it's nice to have little safety checks like that. Then what we do is we get to the compartments, which I've shortened to parts, but that's really not the best abbreviation. We could call it rooms. It'd be the same length. And it would actually be a word instead of like instead of an unintelligible shortening of a longer word. Hey, Rhiannon Journey. But let's not do that right now. I probably will change that to any reference to parts. We'll change it to rooms. So a block can be in one or more rooms. Technically, it can be in 1 to 4 rooms. So actually, we could do a number of things. I'm still thinking about the fact that we have a bit field for the list of the rooms that a block is in and how we can get around that eventually in the long run to remove the inherent limitation that comes with that, but let's not worry about that right now. How's everyone doing? All right, so we start with cutaway, which is 0. This is the rooms. These are the rooms that we're going to cut away. What we do is we walk the hierarchy, starting with the partitions or compartments or whatever that the cursor block is in, where the cursor cohorts are touching. And then as long as cutaway changes when you add the walk to it, then we can recursively walk through. We can say cutaway equals bit.set, cutaway with walk, add the walk to the cutaway, and we run it again, we regenerate the walk. So this is how we step through the hierarchy recursively. I'm interested in how we're going to handle the borders between 2 compartments. We can probably get away with a lot of good stuff here. Rhiannon Journey, is it a bit field for passing between GDScript and C# or some other reason? It's a bit field because a block could belong to more than one of them. And that's just the most compressed, simplest way that we could do that. And it's not an enum because I can't define those values in advance, right? It's like the membership of the compartments that you belong to is figured out during the floodfill. The fact that it could be between 0 and 4 makes me think that we could eventually replace it with a vector. But a vector 4 is a lot more information to store than just a U-long, than a single U-long. But we might eventually switch to a vector 4. But we can do a bunch of fun stuff because we have a bit field. But no, it's not for talking back to GDScript. Though eventually we may use it for that purpose if that has like rendering or UI implications that aren't handled until all the stuff goes back. I don't foresee that being the case, but you know, I don't foresee much, you know what I mean? Diginanigans, you're doing pretty good. You just played around with a 3D tile renderer right now. You have it able to load tile data and dynamically combine meshes into a single tile. Oh, cool. You still need to make displacement maps for the inset tile layers. You need to figure out properly texturing and creating material effects how you want. Nice. That sounds good. Sounds like good progress. All right, so this is how we did it. And then so we would do that. We would get this cutaway thing. And then we would essentially go through all of the coordinates. If a block had any of the coordinates in the cutaway bit field, we would just cut away those coordinates. And then we would figure out what that meant further down in the auto tiler. Like right now, what do we do in the auto tiler when we're determining that stuff? So if we go down to generate tile data, which is before this, we go to generate tile cell data. This is when we convert the blocks into actual tile cells. What we do is we have some checks. So we have this logic of like, well, the cutaway might contain this block, but you know, depending on some of our own stats, we may or may not. We may render or not render. Like the cutaway, like just belonging to the cutaway dictionary, just being referenced in the cutaway dictionary is not the whole picture. But it is an initial step and an important step. So I think what we could do is we can go pretty broad with that. We could also generate some masks and then determine cutaway after that. We'll definitely need to change some of these rules to get the behavior that I want. But the first thing I want to do is I basically want to, for the Z level that the cursor is on, I want to walk the hierarchy all the way out and create a mask from all of that. And then what we're going to do is we're going to step down. We'll step down and we'll start removing compartments from that bit field. Like we'll start by removing the adjacent ones. Well, Yeah. So as we step down, we remove some, and that's what's going to get us that terraced effect, where we step down. It's hard to describe. It's like the opposite of this effect, right? We're kind of terracing in a direction that's kind of like perpendicular to the camera. So it's like... So it's like up and back as we go. It's up and back, and it's going to be down and forward. So below this, if there's stuff below this, you'll see the same. It'll appear like it's in the middle of, you know, one of these other terraces. It's a little different because it's not going to be by coordinate like this. Like this is a very smooth terrace up. The terrace we're going to do is going to be by compartment. So it'll be like the next level up, you'll be able to see whatever compartment is up one and over a little. And in this next setup, and then we'll terrace again after that and after that. And I get that we're going to be not deleting, we're going to be like culling a lot of the ship to achieve this. But I think I've decided that that's okay if it provides us an incredibly robust view into the ship. Like if it maximizes, that's part of the reason why I went from that like forward, like almost like a hood, where like the cutaway would come up towards you. It was like the opposite direction as this one, where you could only see a little bit in each layer, and it like gave you a little indicator of like how many layers down you were, but you couldn't see into any of the layers above you. I want to do this kind of more opening up thing just to maximize the chance that while you're looking at this room, you spot something in one of the other rooms and you're like, oh, I should go over there and do something over there. I want to make it really easy for the player to be able to see in here. So that's kind of what we're trying to do. And then, you know, we're going to struggle. We're going to struggle getting there, I'm sure. All right, so the question is, do we need to generate a mask for this? Or can we can we do this more simply than what we're currently doing? Or if we do a mask, can it just be a bit field? Does it have to be these, which are like hash sets that contain all the coordinates in the mask? Can we just instead have the mask be a bit field? Is that doable? So we've got our recursive hierarchy walk. So what we need to do, so if we supersede this with something, so we'll say private void, we'll say cutaway compartments. I don't know. I'm going to change this one's name just to say cutaway blocks by compartment hierarchy. Might even call it mask blocks by compartment hierarchy eventually, if that's what we end up doing. 3D only, blocks, buffer read only, ulong, part hierarchy. Yeah, I think I would be better off calling this a room hierarchy. I think part is gonna, especially because this game is about spaceships. I don't think this is something we can, I don't think we can reserve the name part for this purpose. But that's yet another thing we're gonna save for refactor week probably, or something I'll do offline, so that nobody following along can understand the code at all, because I'm just always changing everything's names. That's the goal, you know. All right, so vector 3i cursor. So we get the cursor. We get where the cursor is. I'll have this safety. I could honestly have an error here. But whatever. Okay, so we get the parts. We can say if parts is equal to 0, we return. So all this is the same. This is us getting the cursor coordinate and getting the compartments around the cursor. Diginanigans, you'll be honest, you really rarely follow my code to begin with. Just the concepts and me talking through it. That is my hope. I'm hoping nobody actually looks at my code, because my code is horrible. Not that my reasoning or explanations are any better, but yeah. I actually find that typically the less I'm showing stuff and the more I'm coding, the less engaged, the less viewership I get. So I really want to move past this phase of like just deep coding of systems with very little visible behavior, because it is not healthy for the stream to just be stuck in a programming problem for a super long time without showing anything. It's definitely something I'm sensitive about. All right, I don't know if I'm gonna call this cutaway. Well, let's say. All right, no, let's preserve the recursive loop here. Let's do the same thing. So we'll walk the hierarchy. I actually want to walk the hierarchy once. So what we want to do is we want to say I want to walk the hierarchy once before we go into recursion. So let's actually say cursored, which is really stupid, but that's what I'm calling. We'll say cursored room. Cursored rooms. Well, we'll say parts. Cursored parts. Actually, we already know what the cursored parts are, so we're going to say cursored parts. We'll call this cursor coords. It's like cursor parts. So we already know those. So what we want to do is we want to get the adjacent parts. The U-long adjacent parts. These are the compartments next to the cursor, the ones in the cursor. Binge Boy, am I using an event bus? Sort of. How's it going, Binge Boy? We have... Our system is kind of spread out here. Let's get rid of this recursive thing. So we're doing this in Godot, but we've separated our state, our game state stuff, like our simulation layer. That is not running in GDScript. It's not running off of really any nodes in GDScript, except for this, the root tree. The root node, which is our game thing, is hooked into C#. So it's kind of our window into this separate simulation layer that I have that runs off of an entity component system. And so what we do for events, like inputs, specifically inputs, if you're talking about like in-game events, that'll probably be, we'll see. Events is actually a subject that entity component systems kind of struggle with. So we'll have to see. We'll probably rely on signals. We'll see. We'll actually see about that as far as whether rendered objects will send signals back up under the simulation layer, or if that'll be all handled in systems and then the rendering layer is not authoritative. I'd rather not have the rendering layer be authoritative at all. But here's what we're doing for inputs. So our inputs, this is also not, I wouldn't call this a great system, but it handles the domain switching we're doing between the unmanaged stuff and GDScript and the managed stuff. So what we do here is we basically build an event, an input event, as a very simple like array of string arguments. And we enqueue that in the root node. So we go over here, the enqueue input, just somewhere here. And so basically we just have this, we kind of use the command pattern for all of our inputs. So we create a command object of all these arguments in the C# side. And then now we can go through and we can essentially parse each step of the command and then enqueue it. So then we'll have like an input, series of input queues here, like we have an edit queue or like a tools queue or a views queue. And then each system that processes basically consumes that command. So that's a simple command pattern. It'll be interesting to see how we handle in-game events. Everything will probably remain on the simulation layer side. I don't think I'm going to use signals for that. I think I'm only using this kind of command pattern input system just for the inputs. And then I think when, let's say like a character gets to a console or whatever, the movement system might not know that, but like a crew system would probably know that. So we'll see. It's all going to be very system based. But yeah, I do kind of like buses. I just don't know. It's not that I don't like buses, it's that I'm not sure what the character of an event would be. Because I don't like using entities for short-lived things. Like if something just lives for a frame, like an event, an entity is not a good candidate. Or let's say a single frame thing is not a good candidate for being an entity. So there's a lot of different ways you can do that with an entity component system. We'll see. We might end up using tags on existing entities. Thanks for explaining. Yeah, sorry if it was terrible. Big picture, we're trying to make an isometric 3D version of FTL faster than light. So right now we're kind of busy working on tackling the visibility issues involved with having a kind of 3D projection into a 2D world like this. So that's what we're working on. We're working on the tools that let us build this. So we haven't tackled that issue quite yet. But thanks for stopping in. Thanks for asking a question. Hope you're having a good day. I'd be interested if you're working on anything. Hear about that. All right, so... Oh. Did I cut this instead of copy it? Oops. Leave that there. All right, so I don't think I want to recursively walk. What I want to do is start by saying adjacent parts equals walk the hierarchy. Send in the part hierarchy. We send cursored parts. Looks good. Am I leveraging AI in my workflow? I am not. Everything's very hand done. The only thing I've got is I've got JetBrains Writer's like code suggestion AI. And it's not great. It makes more errors than anything else. A future world where I might involve AI on some level might be in testing or localization. Because localization is going to be a pretty big problem for us, but I'm uncomfortable doing anything that I can't verify or that someone else can't verify. And so like I don't know if I want to use machine translation because like I have no way of knowing if the translation is accurate. So I don't know. I can't think of a particularly compelling use case for AI in my workflow. At least the AI people are talking about, obviously, like generative AI. Obviously, the game is going to be full of AI, but it's going to be like utility-based AI and stuff, you know, for, you know, controlling the behavior of the crew members or the other ships and stuff, you know. But that's, I don't think that's what anyone's talking about when they're talking about AI nowadays. So I guess we want this if adjacent parts is equal to 0 return. I actually don't know what we want to do. So what if the cursored compartment has no adjacent parts? I actually don't know how we handle that. But we do want our adjacent. We want to get the adjacent parts at least. Binge Boy, yeah, you have Claude Terminal doing unit testing on your stuff. You're new to Godot, though. You have a web background. Yes, testing. I think testing of especially crazy stuff, like crazy combinatorics and things like that, I think that's a reasonable use case. Obviously, you can't, like, still got to verify, but yeah, I've talked to people who are like RPG game devs, and they're like, I can't test every combination of every skill and every item of equipment and whatever, and like every spell. So like when you hit something like that, I could see that being a reasonable use case of it. I just don't think I would trust it for anything critical or anything. I wouldn't let it touch any kind of asset generation. Partly because I'm using very low resolution pixel art. Like precision is the name of the game when you're doing pixel art like this. There's no way you can generate anything like this to be consistent. Nor would I really want to, if I'm being honest. That would kind of take the joy out of it for me, because I do the art myself, and I actually enjoy it a lot more than I thought I would, as kind of more of a programmer than an artist. I actually really enjoy pixel art, and this is kind of my first major undertaking with it. But yeah, I have some friends that I have a friend that's using Claude to help them understand how like solar systems are created, which is kind of cool. And to like come up with like procedural generation tools. That seems like a reasonable application. At least for, you know, when you're in the exploratory phase. I would be very uncomfortable letting an AI touch any finished product, any like finished asset or aspect of the game. But for testing and ideation and stuff like that, yeah, sure, why not? let's see. So we're going to get, so we've got the cursored parts is equivalent to this cursored mask, which is a mask of, right now we're making a mask of all the coordinates in the compartment that the mouse cursor is in, which is sometimes more than one compartment if where the mouse cursor is on like a wall. So if the mouse cursor is on a wall and there's two compartments, both of those compartments are treated as the cursored compartment. And then we have the adjacent mask, which is all of the blocks in the compartments next to those cursored compartments, like immediately in front of. And then we have everything after that, which we're going to regenerate a different way. So yeah, I don't know what we do if we don't have an adjacent, if there's no adjacent compartments. Let's not think about that right now. So we get our cursored compartments, we get our adjacent compartments, and then what we need to do is we need to figure out everything else. So U long. We can say combined. Combined is the wrong word. We could say... we could say like foreground. We say obscured. Well, it's not obscured, it's more like obscuring. Blocking parts? I don't know. Blocking is not a good word. Occluded parts. That's what we're going to call it. Occluded parts. So occluded parts is going to be, we walk the hierarchy. We'll walk the hierarchy from the adjacent parts. Maybe we want to forget about the adjacent parts for a minute. Just because it's this middle step that I'm not 100% sure of. All right, so we get all these parts. We actually probably don't want these to be local. We probably want these to be member variables. So yeah, let's make these member variables here. Yeah, occluded is not the right word, is it? It's more like, they're more like the occluding. Maybe we just call them blocking, even though that's really dumb. Because that is what they do. They are blocking. But I don't like it. I don't like using that word, since we have blocks is already such a defined term for us. But whatever. Parts is not the right word to use either, and yet we're using it. Alright, so we're going to say adjacent parts equals WL. We also say bit.clear adjacent parts. Adjacent parts equals bit.clear. Or not adjacent parts, blocking parts. So we'll clear all those. Set these up. Diginanigans at BingeBoy, you come Diginanigans, you come from a web dev background as well. You're building up a game using TypeScript and Godot, using a fork of it that has it fully integrated. Oh, that's so cool. I didn't realize the TypeScript thing. Makes sense. All right, so we can do all of this. Oh, so the occluded one, this isn't just a single step walk. This needs to be... This needs to be this whole thing. How is this allowed? I swear I asked them for only instrumental music. Now I have to check what I told them. Instrumental only. Yep, that's what I thought. So as long as I can walk the hierarchy, I will do so. Actually, I guess if... No, yeah, so we don't do this... Hold on a second. Ah, I see. How do we do this here? OUL, parts. This is not quite right. Blocking parts is already clear. We may or may not actually need this information, but I think we do. We could probably do this whole thing in a single function, in which case these don't need to be member variables. I'd rather if they weren't, but... yeah, let's actually go back to that. I actually don't want these to be member variables. Call these occluding, not occluded. I should probably call those things cursory as well, instead of cursored. We've got cursory parts, adjacent parts, and occluding parts. All right, so we got all that. We have 3 different layers. We have, here are all the compartments the cursor's immediately on. Here are the compartments that are immediately next to those. And then here are all the remaining compartments that are in front of us on the same Z level. Shenanigans, it makes it easier for you to reuse code between your authoring tools in the actual game as well. You can use Quick.js to compile the native code for a production build to eliminate all the just-in-time stuff. Nice, nice. That is cool. All right, so we can get all of these. Not quite sure what we do if we're like on the edge and there aren't any compartments for one of these categories. So let's say we've got all our compartments. We've got our compartment lists. We probably just need to iterate through all the blocks on this Z level. So the easiest way to do that is to define, like we have down here, a start and an end. So we say start. We should probably say if input bit dot has input Is there one of these that returns a bool? No, it's not. You could say is clear. We'll just say not has. The input is empty. We can't do anything. Honestly, I should probably throw an error, but that's fine. Actually, we probably want to do it this way. All right, so now we can iterate through. So now we can say for I is start, I is less than end. So now we can iterate through on our Z level. Wonder how much more. So how are we going to do this? So we need to figure out where the cutaway is. Then we need to go up a level and figure out what's behind that. And we need to go down a level and figure out what's in front of that. And then we use that to essentially do this again. To do the occlusion part again. From those new compartments. Which is why I kind of want to try this without the adjacent part thing. Just see what it would look like in a simpler case. And then we could always add the adjacent parts back. That's probably the right way to do this. So what we're doing right now, instead, is we're creating a mask of all the coordinates that we want to potentially cut away. And we have some logic about that. It's not really what I want to do. So I essentially want to make sure I'm cutting away. So let's do this. Let's do this. So let's say... Man, what if one of the adjacent parts is in front of another adjacent part? Or what if a cursor part is in front of one of the adjacent parts? There's some crazy like circular things that can happen with like crazy long winding hallways and stuff. So I think I need to check against that. So we need to say vector 3i block coords is blocks.getI. Blocks.get coords I. Actually, no, I want the actual block, don't I? Block. Block.get I. I probably also want the coords, to be honest. But maybe not. So we can say, yeah, because we do need to add the coords to this, don't we? So we can say vector 3i coords equals blocks dot get coords. We can say, well, we don't necessarily need the coords, do we? What we can say first is we can say if bit.has block.parts. So if the bit has an occluding part, but if it has an occluding part and it does not has any, actually yeah, this is all has any. This isn't has any. We have any of that, but what we don't want is we don't want to accidentally have, we can say cursory parts or adjacent parts. We could have this be separate. Let's say adjacent parts. Say cursory parts. Okay, so if we're considered part of the occluding parts and we're not one of the adjacent or cursory parts, then what we want to do is we want to add to cutaway Cutaway. Add. This is where we put in blocks.get coords I. So that's just for the base layer. The thing is, we need to then go up and down. If we want this terraced effect, we need to go up and back, so we need to do this process again. So maybe doing this all in one function, or maybe this, we need to write this in a way that's... Maybe I need to write this in a way that I can loop this. All right. Because what I'm trying to do is, to get this terraced effect, we're essentially going to go up a level and then do the same thing. Oh, but we need to do it. The hierarchy needs to go backwards. Does it? Does it though? Or do we just need to identify the compartment that's up? Well, let's talk about down, because I think down is easier for me to visualize, because down we actually are going to be repeating this process. Do we need to look in the hierarchy and see which compartments the cursory compartments obscure? That's maybe how we need to do this. So we basically go through the part hierarchy. We would need to search through the part hierarchy and figure out which compartments the cursory compartments obscure. And those compartments are the ones that we want to showcase. Yeah, I'm not quite sure how to do the up and back part. So let's do the down and forward part. So we can do this. So we can do this for the base Z layer. And then the thing is, we need to start going up and down. So let's go down first, because I think we can figure that out. So we can say for Z, for integer Z equals cursor coords dot Z minus +1. We need to say if cursor coords dot Z is not equal to or is less than hull hull levels, right? Hull levels. That's the number of levels that we support. -1. So this is going down. So from here, we can redefine the start and the end indexes. Where Z equals Z. All right, so we go through that, and now we can go. Now we can once again do this. And then so we've gone down. So now what we want to do is we want to treat the adjacent parts. We want to treat the adjacent parts as if they were the cursor parts. So we restart this search. Every time we go down, we're going to restart this process, but one set of compartments forward. This should look really cool on especially bigger ships or space stations, because it should essentially give you this big open terraced view into the ship based around where your mouse cursor is. Which I acknowledge is maybe cutting away a little more of the ship than I would have liked, but you'll still be able to see the ship in all its glory when you either aren't mousing through it or, you know, you've zoomed out a little bit and you're doing the exterior ship stuff, like targeting other ships with your ship. Because that's going to be like a separate zoomed out view. The zoomed in view is really all about moving characters around the ship and stuff like that. Manning stations and, you know, making sure, you know, opening doors and closing doors and stuff like that. I don't know if we want to go straight to cutting things away. We might need more of an intermediate step, because when we do this, we generate the mask, and then we, like, evaluate some rules before we... Or we then use the mask in a following step, and we evaluate some things about it to achieve that effect we want. So I actually don't know how direct we want to be with this, but let's try it. Let's try to be direct. Shenanigans, you think pulling away more is better than less anyway? As cool as the ship designs may be, from a player's perspective, you're more interested in what's going on inside. Yeah, I think that's ultimately... I agree. I think that's ultimately where the priority should be, especially for this view, for this window. But I don't want to do it per cursor, because that's what we were doing before. We were like, everything was very tightly related to where the cursor was from, like... And it wasn't very aware of the compartments. I think doing it on a compartment basis will keep it from feeling jittery, like too much is changing. So the walls are hidden based on where the mouse is. Yeah, Binge Boy. Diginanigans from there, it's about the UX of how easy it is to reveal what you want revealed and making it look good. Yeah, that's what we're working on. So here's like an example from like our previous attempt at doing this, which is like you build the rooms, whatever number of rooms, doesn't really matter. This should still work. I don't think I've changed anything. So if you start making compartments, and so if I'm in this compartment, it changes what's being cut away. So if I make more compartments, so like, this isn't bad. It gets a little awkward when you get to the back, but whatever, we could fix that. This is okay. But I don't like the way that it kind of just cuts out everything in front of you, which is kind of where I got the idea to terrace down, which, like, what if you just kept stepping down? So the terrace level that your cursor is on is going to be bigger because it's not going to be just the compartment you're mousing in, but the next two. I mean, the next immediate ones. So like ones that would be considered adjacent. So like these two are considered adjacent. Actually, all three of these are considered adjacent to this one. So you'd be able to see these three rooms. It would terrace back. And then if there were rooms below this, you would start getting that same terrace effect, but down and forward. So that's kind of what I want. And instead of only seeing one thin strip on each terrace level up, I want you to see the entirety of the next room that's above you, minus whatever needs to be cut away so that you can see this room. So I think we're heading in the right direction, but clearly we have some more work to do. It's cool. Thank you. Yeah, we have a very complicated auto tiler that makes it really easy to like redraw based on what you can see or not see. The thing is, now we're just picking the good values, right? We're just picking what to see. We have a system that could kind of show us whatever we want. And now, yeah, now we just got to, you know, pick good values, which is always the thing. Like whenever someone shows me like a really cool procedural generation tool or something like that, I'm like, that's really great, but how do you pick the good values? Like, I know you can generate a ton of stuff. But it's like you got to avoid the 10,000 bowls of oatmeal problem. You got to generate only good things. So that's what we're doing. Where it's like we could pick however, we just got to pick the right things. That's what DIGITAL was talking about. The UX of like how you reveal what you want to reveal. So we're going to go one level down. We'll go through all the blocks in that level down. And then what we need to do is we basically need to go through this step again. I'm going to say ulong cursory parts z equals adjacent parts. Oh, well, this is for the Z loop. This is actually a little tricky. How are we going to do this in a way that's totally... Actually, I guess what we do is we start like this. DIGITAL in your game, you're going more with mostly handcrafted stuff, but then various sections that can contain different other handcrafted content. Yeah, that's what I always advocate for. I advocate for have the individual components be handcrafted, but it's okay if the thing that glues them together is like procedural, right? Like if you make a bunch of rooms, so you know they're cool, interesting rooms, and then if you have a system that like randomizes the order of the rooms, sure. That's a way you can get additional content without having to create more stuff. I think that's fine. I just think when the elementary pieces aren't handcrafted, that's when you start running into problems. Okay, so we get our cursory parts, we find their adjacent parts, and then we occlude the rest. Problem is when we step down, we need to redefine. I want to get rid of the concept of the adjacent parts. Now there's just going to be occluded. Maybe we don't want to say occluded and occluding, but there's like going to be the source. There's going to be like the input parts and the output parts. So maybe that's just what I say. So how do I do this? How do I feed this in, the initial set of adjacent parts, and then have it just eat itself after that? I think I need to define something out here. You can just say variable input parts equals adjacent parts ulong maybe what we do is we say output parts long. We say output parts equals adjacent parts. Is that the last output? No, that doesn't make sense. The shenanigans. As an example for tavern specifically, you got a few default rooms, then potential places for where the counter is, and potential doors to extend to new rooms. Then randomizing textures, materials, and lighting a bit so they all feel unique. Yeah, that's great. They should call it procedural arrangement rather than procedural generation sometimes. This is maybe where I need to have a recursive function. As I go down. Or I just need to find a way of getting the output from the last step set up as the input of this step. And I need to do it in a way that makes sense. Because we get rid of the concept of the cursory parts after the initial step, and then we work off of the adjacent parts after that, at least for when we're going down. So we need to say something like input parts. Okay, so maybe it'll be clear to me if you, procedural composition. Yeah, I like that. Let me think about this step +2. Like, we come out of this step and we go back into the next Z level. Let's say we've got like 3 or more Z levels to go through. So forget about the original one. Let's say we've got the output from the second one. The output from the second one is there's going to be the occluding parts, which are all of the parts in front of... Oh, I skipped a step. I skipped something we need to do first. We need to even figure... We don't even know what those parts are going to be, what those, like, original parts are going to be. What we need to do... So we actually do need to go down a Z level. So maybe we do it like this. So we go down a Z level. We basically need to go through the adjacent parts, figure out we need to grab the edge, the lower edge of each adjacent part, wherever that is. Figure out what compartment is below that, at that lower edge. All the compartments that are below that. All right. And that will be the start for our next loop through. Because that's what we need to do. We don't actually know what compartments are down below us at that edge. So we need to say if... This is where it would be a little easier if we just generated a mask from the adjacent parts, because then I could just iterate through only those blocks instead of doing this. Or we're going to say if not bit.has any adjacent parts. We're going to say, oh, we need to get the block first. So if this block belongs to one of these adjacent parts, then what I need to do... Oh, no, that's not going to work. It's going to be blocks. We need to get the coords. Maybe I don't want to do it this way. Maybe I do want to do a mask. For instance, we could record that information right now, couldn't we? It involved making a hash set. Or like a list. We're already searching through all of these. All right, let's try to do it without doing that for a second. Vector3i coords equals blocks dot get coords I. Then what we want to do is we want to say upper block equals blocks dot get. We want to say get. We want to say coords plus vector3i dot forward. We want to try to get the block above us. We want to say if coords.z no, that doesn't make sense. We need to go the other way. You can say getter default. Coords plus vector3i forward. Just wanted to make sure we handled any a boundary issue. So we can say if bit.has any, if upper block.parts, so if the block above us doesn't, we're going to say if it does, we can say positive z block, or it's actually negative z block. Negative z block. Negative z block has that. Then what we want to do is we want to say positive x block we want to actually say positive xy block equals blocks dot get or default coords plus vector3i dot right plus vector3i dot up. I really want a different way of doing this, of the vector3i like basic vectors, like the direction vectors. I'm gonna rename these. So we get that, and now what we want to do is we want to say if bit dot has any. We want to say if not bit dot has any. Positive xy block parts, including no adjacent parts again. We're trying to find the edge of the adjacent parts. the lower edge. So if we find one of these edges, hold on a second. Yeah. Okay. So we're finding the edge. And then what we're gonna do is now we need to build a new set. So we find all of these edges. So this is what we do here. So for Z level, we got start, we got end, and we are going to have, for right now, I'll just define a new set of parts. Call these lower parts. That's funny. I'm just going to call it parts for now. I'll come up with a better name for it in a second. You could say adjacent parts Z. I don't know. Yeah, whatever. Yeah, lower parts is fine. So then we want to say lower parts dot, we want to say bit dot set. So if we found the edge here, we want to get, no, this doesn't make any sense. We want to see, what we want is actually, we want to say is negative Z block. We want to see if it's not empty. The negative Z block is not empty, we can proceed. Oh, no. I had it right. So what we do is we go through all the blocks, we pick a block, we look above it, we say, is the block above this block one of the adjacent blocks, like part of the adjacent compartment? If it is, then we want to check the block in front of that block. And if the block in front of that block, of that upper block, like I was saying, is not part of that compartment, then we found an edge. And then so we want to go back down and over to that edge. And we want to add those compartments. Oh, we need to also have this part though. This is actually plus vector3i dot up plus vector3i dot forward. Then we can say bit dot set lower parts. We're going to call this lower adjacent parts. We're going to set those. We're going to say blocks dot get or default towards plus vector3i dot right plus vector3i dot up dot parts. What if we try to set okay, no problem, no problemo. All right, so this will get us the set of compartments that we're going to use on the level 1 lower. So we need to build all of those up. And then once we've done that, I'll say lower adjacent parts equals bit dot set I can invert the conditionals here. Same thing here, right? All right, so we're going to go through that full loop. And then now what we're going to do, so now we've defined the lower adjacent parts. Now we're going to say u long lower occluding parts. We'll initialize that. And now we can do this walk. I think there's a way to do that. Binge Boy, how do you keep track of the state the ship is in? Do you mean overall, or do you mean on like an individual level? Do you mean like, oh, a fire has broken out in this compartment? Or like... So on a broad level, each ship is considered an entity and has a buffer. It has a dynamic buffer of all of the blocks that are in it, stored very densely. So a ship can interrogate each of these blocks and get a bunch of information out of them about the particular block. A ship also has a bunch of compartments and can interrogate the compartments and get information about those. So it depends on how low level the thing you want to know is. If you want to know whether power is getting to this particular block, you can ask the block. If you want to know if there's a fire in the room or if there's any oxygen left in the room, you can ask that. You can ask if the compartment is like exposed to outer space. So there's a few different levels of fidelity that you can answer that question at. Is there a data object of the entire ship? There is an entity. And so an entity being an entity, it has a bunch of components. So a ship does know about things like its position, but it also has further down data structures that aren't themselves entities. They're like you don't want a block to be an entity because that's ridiculous. There's too much of it and it's too tightly related to other things. So you just make the blocks individual elements of like a buffer, and then you assign that buffer to the ship. So it steps down. But yeah, the ship itself is an entity and has components and is processed, and those components are processed by systems. So if someone has a buffer, they have a buffer component. And so if you want to process their block buffer in a system, like in our auto tile system, then you just process everyone that has a block buffer component, and then you bring up the actual block buffer itself. I like doing it this way. It's a little awkward. There are things that are hard, but I prefer this to just the web of references that is like the object-oriented approach. All right, so we're doing... Yeah, I think I see a future where we can do this on multiple levels, and the levels don't really need to know about it, and we have a higher level function that is managing that. could be good. This could be cool. All right. So we do that. We got our lower lower occluded parts. Adjacent parts. That's no good. What we need here is lower adjacent parts. All these returns are erroneous. I need to figure out an alternative to that. You think you're getting it? Thanks, me too. I think I'm starting to get it. Diginanigans, that's one thing you're still getting accustomed to, how the idiomatic way of doing things in Godot is versus how you typically program things and find yourself moving away from doing stuff in Godot itself. Yeah, Godot is incredibly flexible, to be fair, which is kind of one of its greatest strengths. Instead, you're using it mostly as a stage and rendering target. Yeah, that's similar to how I'm using it. So if you've got like a lot of opinions about it, you can kind of mess around with whatever you want. So if I've figured this out, so we do this, and then we basically do this same. So then we need to loop through all of the blocks again to add them to the cutaway. So what we would say here is we'd say we'd have to loop through a second time. We would need to say if bit has any, if it's one of the lower occluding parts and it's not one of the lower adjacent parts. This is a little wrong. I already see a couple of ways in which this is wrong. But it'll work to an extent. It'll be a start. Then we can cut this away. Okay, now what happens if we complete this loop and we go down to another Z level? Lower adjacent parts is 0. What I need to do is I need to define lower adjacent parts out here, I think, rather than defining it in here. And instead of saying 0, what I actually need to say is adjacent parts. No. How do I do this? How do I do this in a way that I can keep looping and going down? So we get the coordinates out. This, I can't just plug this in. Maybe what I do is I say lower adjacent parts equals 0, and I say u long upper adjacent parts equals adjacent parts. Because that's kind of what we're doing, is we're looking at the upper adjacent compartments and using that as a starting point here. So we can say lower adjacent parts is 0. We can say upper adjacent parts is adjacent parts. We can say, so then here we would say if not bit dot has any upper adjacent parts, maybe it actually works this way. Maybe we say u long upper adjacent parts equals lower adjacent parts. Maybe we do it like this. And we kickstart it by setting it like this. And then after this, So we can set this and then we can clear this. We can say lower adjacent parts equals bit.clear. So we can feed the lower adjacent parts of this layer as the upper adjacent parts of the next layer and then use. Okay, I think that's how we do this iteratively. This is definitely one of the bigger refactors that we're doing all in one go. This was simpler in my mind when I came up with it last night. But it's good. I think this is going to work. I think figuring out the implementation details is a bit of a trick. But I think it's going to work. There's definitely some edge cases, like literal edge cases that we need to sort out. But otherwise, it's pretty good. We also need to figure out how to go up, though. So we need to say if cursor coords.z is greater than zero, then we can do the upper part. Okay, and the upper part is interesting. So the upper part is going to use both the lower and the adjacent and the. So we want to say ulong combined parts equals cursory parts or adjacent parts. We want to use both for the upper section. So we go up and away, and we do that by, we're going to do the thing like this, where we go through every coordinate. Do this first. Did I say z++? This is z minus. Oh no, this is z++. The one we're doing now is z minus minus. For integer z equals cursor coords. Nope, not this one. Cursor coords dot z minus 1. Z is greater than or equal to 0. Z is equal to 0. I don't know if we want to do this. We want to say greater than 0. Z minus minus. We could actually call this, we could actually say so when we go up, what we do is we do the same loop, go through all of the coordinates for this layer. This is pretty involved. I'm a little concerned about how intense this is going to be to run for the auto tiler. but hopefully it's okay. Say 4. We'll go through all of the blocks. So grab the coordinates. And now block. Now we're looking at the positive z block. And that's vector3i dot back. And what we're going to do is we're going to say if not bit dot has any positive z block dot parts, combined parts continue. It can't be combined parts. It's got to be we'll just call it adjacent. It's not really adjacent, it's also including the cursory parts, but it's okay. Do the same thing we have here, where we define do I have this right? I think I have this reversed on accident because I got confused about the direction. So here we're going down. It is negative z block upper. Oh, okay, I'm getting tricked by the direction of z in terms of positivity and what I consider up and down. So we're gonna flip this here. Ah, right. So here we're gonna say upper adjacent parts equals these two. And then in here we're gonna say u long lower adjacent parts equals upper adjacent parts. And we'll feed in the lower adjacent parts. And we'll clear the upper, right? I really want to make these like a struct that has like functions, like static functions on it, instead of just making it a raw u long. But that is also a refactor that I don't want to do right now. Sorry, getting some text messages here. All right. All right, so now here, so we got positive z block. And now we're going to do negative xy block equals blocks dot get or default towards plus vector 3i dot left vector 3i dot down plus vector 3i dot back. We're going to call this the negative XYZ block, not XY. That's not exactly accurate, but okay. What do I do here? If it has any of the lower adjacent parts. So we find the edges, but instead of looking forwards, now we're looking backwards. The question is... I actually think I want it to be like this. I want it to be like positive X. Wonder if we can do some of these checks earlier here when we're doing this loop. Wonder if we're like maybe doing too much work in the other loops. We could at least get started. Yeah, I don't know. We can improve that later. So we're gonna say positive X block positive. We're gonna AND these. I think that's right. So if we find an edge in either direction, we're going to use that. So here we're going to say the opposite. We're going to say upper adjacent parts. Dot set upper adjacent parts. Left. Down. Yeah, we're going to do this a little bit of a different way. I can see already, because of the way we want the edges to work exactly between the levels, some of the finer stuff we're doing with our current method. We're going to do these loops a little differently. But for immediate testing, just to see if we're on the right track, this might be okay. The real problem is the auto tiler needs to know how to interpret all this information. And that's a separate problem. So here we go. We add this part. So that's the upper section. This is within the Z level. Okay. So we're going to call this upper. Occupied parts. If we did this right, this is just going to give us like this awesome terrace effect. Whether we did this right or not is no guarantee for sure. This will do something though, so let's try this. I don't know what this is going to do, but we're going to try it. And we'll just forget about everything else except the interior cutaway. And also, we don't need to record this as anything. Put this here directly. Let's see what we did. If we don't get a crash, I'll be surprised. So it's not currently doing anything, which is interesting. The thing that's happening right now is the interior cutaway system. So what if I start terracing stuff? Okay, the terrace doesn't seem to do anything. Huh. Okay, not doing anything. Cutaway is the correct thing, right? This could be a problem with the way the auto tiler interprets the cutaway. We kind of want the auto tiler to just trust right now the way we're doing this. I don't feel like there's any guarantee that we did anything correctly though. I feel like masking could be a good way to do this. Also make it easier to debug. Is there an easier place that we can do some of this? So like we go through this whole process. This is the initial part. There's an argument to be made that these functions are very similar, and this could just be a function, and then we have another system that manages that for us. So we could have like, I feel like walk hierarchy should be underneath this, but so here let's make a function. I'm gonna try to do this in a way that's easier to debug, so we can maybe go like layer by layer. Cutaway, let's say cutaway blocks by compartment. Let's say cutaway Z level by compartment. For 3D blocks. For blocks. For read only, long. Part hierarchy. Probably some other stuff I need to pass in. We're gonna try to do this for a single Z level and see if we can just make that work. So it's essentially this part. Oh, there's the part of the cursory parts I'm not thinking about. So what happens if we're just in a single room? Oh, there's stuff that needs to... Oh, no. I get it. I can think of quite a few problems with this. One is, I think my test case is too simple. I need to get this working in a primitive situation first, which is like, there's one compartment per Z level. Or I need an early out so that we just switch to a backup cutaway system in that case. So I generate all this mask data. Where do I actually do the cutaway part? So we just go through all of those. I don't really want to build that. I'd rather go straight to the cutaway. Although I do need to rethink some of this. The auto tiler has its own logic for how the cutaway works. So like cutaway, so for like a deck layer, we've got cutaway contains. If cutaway contains our coordinate, but we happen to be above the cursor, and we're above the cursor. So this is probably part of the problem. If we're above, no, we need both. It needs to be both. Oh, there's an easier way to build this, at least for the we're going up part. Let me see if I can knock this out real quick. I've got to go soon. I was trying to start early today, but it didn't happen. I want to put down the basics of this. So we're going to actually utilize this initial part. So this, doing this stuff per Z level, I think is a little wrong. I think what we want to do is we want to handle our basic case. So cursory parts, I think these early returns are causing us some problems, some pain. I think we actually need I think that's wrong to do it this way. So cursory parts, because if blocks doesn't contain the cursor cores, we just return anyway. I guess so this is where we would say, okay, there's nothing here. What we want to do instead, actually, we want to switch to an exterior cutaway system, if that's true. We're already checking this, though, aren't we? Yeah, we are. So this is okay. So let's do the adjacent. I think this early return is causing us some pain. So what is the case for if adjacent parts is 0? Like if we're on a cursor or we're in a compartment all by itself. Let's handle that case. So in this case, we would say how do we build these masks? Why do I need to know the exact compartment? I don't quite understand why I need to know that, but okay. All right, so let's handle this initial case. There's only one compartment, or there's only the immediate compartment that the cursor is over. If that's true, we do this. Am I not allowed to do that? We're going to handle this for exactly one case and see if we can get this to work. We're going to say if, say vector 3i, no, we'll say block equals blocks.get I. We know this is safe. And this with a return for extra safety here. All right, we're going to try it this way. We're going to try for a very simple use case to start, just to make sure what we're doing is kind of working. So if it's empty, we can just continue. Otherwise, we're going to... Do I not need anything about this block except this? I can just do this. We're going to see if this at least lets us see into the thing. This should be sufficient for like very simple. We need to build in stuff for very simple, for trivially simple use cases like this. Like we have a single layer. Make a room. All right. So that works for that. So we're popping the roof off. So we need to refine this so that we do things like hide the front walls. Okay, I can work with this. I need to extend this quite a bit, but I don't love this monolithic function we're writing. I think we're going to write it a little differently. I think there will be a controlling function, and there will be like a more of a looping series of looping subfunctions. Cool. Yeah, I need to go. But this was fun. I say fun. We didn't really demonstrate anything, but I think we're on the right track. We'll be back working on this Friday. I'm taking tomorrow off. Yeah. I gotta run, so I can't have a long outro here. But I really appreciate everyone for hanging out. Some new faces, like Binge Boy. Welcome in. Everyone else who was just lurking, I appreciate you being here. You don't have to say hi. I just appreciate people spending their part of their day here with us. Yeah. Thank you all so much for watching, and I'll see y'all next time. Bye.